Hello, learners. Good morning. I just want to explain this question coming from the mock exam for supplementary learning on this topic about force and moment. So let me read the question. The member of in this figure, as shown below, is subjected to a force of 6 kilonewton. You have your 6 kilonewton, and then you have where the distances here is 6 meters, and there's 1.5 meter here in radius. So that means from here going to here is equal to 3 meters. Okay, so the first question is calculate the moment of the force 6 kilonewton, or is 6 kilonewton about A. Okay, so what would be the moment here? Let us consider this rotation. Okay, so first, okay, you have here, take note that the angle here is given to be 45 degrees. So of course we'll, if you are going to take moment here, first basic approach is to get the components here. Okay, here adjacent to 45, this is just 6 cosine 45 degrees, and then this one is 6 sine 45 degrees. Okay, so let's just take moment here at A. This is all, I think this is all in clockwise direction. Okay, these are all in clockwise direction. So for letter A, moment at A is just equal to 6 cosine this one, okay, 45. This is the perpendicular distance from this point, okay, to point A. So you can just have to, okay, multiply by 6 meters, and then you have, for this force, the perpendicular distance is 3 meters. The moment arm, I should say, from, it's the same here, okay, to here is equal to 3 meters. You say 6 sine 45, and then distance is equal to 3 meters. So moment A here is equal to 38.183. Okay, take note this one is kilonewton. That means this is also kilonewton meter. Okay, so how about question number 2? Question number 2 is asking us to solve for, okay, let me read. Determine the angle of the force 6 kilonewton. This 6 kilonewton. Okay. With respect to the x-axis, which will give you a maximum moment at point A. Okay, in other words, how can we calculate, okay, the moment which is maximum here at A? Okay, what would be the angle? This one should be, if we are going to have it here, this one should be perpendicular. Okay, so how we are going to get that perpendicular? Okay, so if you have this angle which is theta, for example, this one could also be equal to theta. Okay, theta, and this one should be like beta, for example, beta, or 90 minus theta. In other words, this angle theta plus beta should be equal to 90 degrees. Okay, so if this is theta, this one is also theta. Okay, so how are we going to calculate the theta? Since we have this 3 meters, theta is just equal to inverse tangent of opposite over 6 adjacent. So theta here is just equal to 26.565. 26.565 degrees. Okay, so this is theta, this is theta, this is also theta. So the question is to get the angle with respect to x-axis. So your angle is equal to 26.56. This is 26.56 or 565 with respect to x-axis. That will give us a maximum angle of maximum moment at A. Now if we are going to calculate moment at A here is just equal to, let's say, this distance. Okay, this distance from here to here is C. So you just have to multiply 6 kilonewton multiply by C, which is in meter. Okay, this one should be in meter. C is just the hypotenuse of this triangle. Okay, you have this triangle. Okay, so you have 3 squared and then 6 squared. So it will give us 6.71 meters. So in other words, moment A is just 6 times 6.71 meters. Okay, so that will give us a maximum moment of 40.25. Take note, this one is kilonewton, so this one should be kilonewton meter. Okay, what's the last question? What will be the angle of this force F that will, with respect to x-axis, which will give us moment at A here equals to 0. Okay, let's copy this one. Okay, so what would be that angle that will give us moment here at A equals to 0? If we're going to connect this one, okay, and then moment equals to 0 when the force is going towards A or away. Okay, it could be going here or going here, as long as it's in one direction, going to this point A. Okay, so what is the question? What is the angle with respect to x-axis? Okay, so what is this angle coming from here? Okay, theta. Let's say theta here. So if we're going to draw it here, okay, force here is F here is equal to 6. Okay, if this is, earlier we had an angle like this is theta, and then this one is 90 degrees, and then this one is theta. Okay, so what is that particular angle? It is just equal to 90. Okay, so the question is, with respect to x-axis, what would be the angle going here is theta, then theta x for, okay, for a moment that will give at A, moment A is equal to 0. So we calculated earlier this 26.565. Okay, in other words, this one to here is 26.565 degrees. So the angle coming from here over going here to this force, which will give a moment of 0, let us say I write it, theta x is just 90 degrees plus 26.565. Okay, so that will just give us 116.565. Okay, so meaning this angle will give us a moment equal to 0. Why? Because the force here, 6 kilonewton, is directly towards point A. Okay, just in case you have it here, so this will also give us a 0. This will be your new angle. Okay, so if your F is here, it will still give a 0 going in the direction. So what is this angle? Let us say this is our second solution. Okay, alternate solution. So it's just theta x here is just 90 degrees minus 26.565. 565. Okay, it's the same. Okay, it's the same, uh, different angle, but the concept is the same. That will give you a moment equal to 0. Okay, so I think that's all for today. If you have questions, just drop it in the comment section. Okay, or you may send email to me. Okay, thank you.